Hello smart learners, today you will learn about loops and decisions in C++ with the help of examples. Content of this video are for loops with the help of definition, code, algorithm, flowchart, and explanation, multiple initialization and test expressions, the while loop, the do loop, when to use which loop, the if statement, multiple statements in the if body, along with their definition, code, algorithm, flowchart, and explanation. Let's first discuss what is loop. Loop causes a section of your program to be repeated a certain number of times. Repetition continues while a condition is true. When the condition becomes false, the loop ends and control passes to the statements following the loop. There are three kinds of loops in C++: the for loop, the while loop, and the do loop. Let's first discuss for loop, which is easiest loop in C++ to understand. The for loop. All its loop control elements are gathered in one place, while in the other loop constructions they are scattered about the program, which can make it harder to unravel how these loops work. The for loop executes a section of code a fixed number of times. It's usually, although not always, used when you know before entering the loop how many times you want to execute the code. Let's see it with the help of an example. Let's do its code. In this example, for opening bracket j is equal to 0 is initialization expression separated by semicolon j less than 15 is a test expression, whereas j++ is an increment expression. Let's code this example. Okay, let's first define a loop variable int j. Then we will loop from 0 to 14. J less than 15 is actually 0 to 14, as j is equal to 0 right now, displaying the square of j, which is j static j. Cout handle returns 0. Okay, now let me run this code. Okay, here's the output. Now let me tell you how does this work. The for statement controls the loop. It consists of the keyword for, followed by parentheses that contains three expressions separated by semicolons as mentioned before. These three expressions usually but not always involve the same variable, which we call the loop variable. It's defined before the statements within the loop body start to execute. The body of the loop is the code to be executed each time through the loop. In this example, loop body consists of a single statement, j static j. This statement prints out the square of j followed by two spaces. The square is found by multiplying j by itself. As the loop executes, j goes through the sequence 0, 1, 2, 3, and so on, up to 14. So the squares of these numbers are displayed 0, 1, 4, 9, and up to 196. Note that the for statement is not followed by a semicolon. That's because the for statement and the loop body are together considered to be program statement. This is an important detail. If you put a semicolon after the for statement, the compiler will think there is no loop body and the program will do things you probably don't expect. Let's see how the three expressions in the for statement control the loop. The initialization expression is executed only once, when the loop first starts. It gives the loop variable an initial value. In this example, j sets to 0 value. This test expression usually involves a relational operator. It is evaluated each time through the loop, just before the body of the loop is executed. It determines whether the loop will be executed again or not. If the text expression is true, the loop is executed one more time. If it's false, the loop ends and the control passes to the statements following the loop. The increment expression changes the value of the loop variable, often by incrementing it. It is always executed at the end of the program, at the end of the loop, after the loop body has been executed. Here the increment operator plus plus add 1 to j each time through the loop. Now how many times the loop is going to execute? The loop in this example executes exactly 15 times. The first time j is 0, this is ensured in the initialization expression. The last time through the loop j is 14. This is determined by the test expression j less than 15. When j becomes 15, the loop terminates. The loop body is not executed when j has this value. The arrangement shown is commonly used to do something a fixed number of times. Start at 0, use a test expression with the less than operator and a value equal to desired number of iterations, and increment the loop variable after each iteration. Now what happens when there are multiple statements in the loop body? Of course you want to execute more than one statement in the loop body. Multiple statements delimited by braces, just as functions are. Note that there is no semicolon following the final brace of the loop body, although there are semicolons following the individual statements in the loop body. This flowchart is basically the life story for a loop told in steps. First, it kicks off an initialization expression, then it checks the test expression to see if the loop should keep going or call it quits. If false, it gracefully exits. If true, it dives into the body of the loop where the real action or work happens. After finishing the task, it runs the increment expression to update its progress and then jumps back to test again, repeating the cycle until the condition finally says nope, we are done. Now discussing multiple initialization and test expressions. You can put more than one expression in the initialization part of the for statement, separating the different expressions by commas. You can also have more than one increment expression. You can only have one test expression. Here is an example of it. This example has a normal loop variable j, but it also initializes another variable alpha and decrement a third beta. The variable alpha and beta do not need to have anything to do with each other or with j. Multiple initialization expressions and multiple increment expressions are separated by commas. And actually, you can leave out some or all of the expression if you want to. You can write it like this as well. It is the same as while loop with a test expression of true. We'll look at while loop in the next example. So what is while loop? The for loop does something a fixed number of times. What happens if you do not know how many times you want to do something before you start the loop? In this case, a different kind of loop may be used, which is called while loop. When the number entered is 0, the loop terminates. Notice that there is no way for a program to know in advance how many numbers will be typed before the 0 appears. That's up to the user. Let's see its code. Make sure n is not initialized to 0. Int n is equal to 99. Here loop until n is equal to 0. Cn is reading a number into n. Cout until and return 0. Now we will run it. Here is its output. The user enters a number and the loop continues until 0 is entered, at which point the loop and the program terminate. The while loop looks like a simplified version of the for loop. It contains a test expression but no initialization or increment expression. It has no semicolon here and it has single statement loop body. It can also have multiple statement loop body as well. It shows that as long as the test expression is true, the loop continues to be executed. For example, and not equal to 0 is true until the user enters 0. This flowchart is the story of while loop in action. It starts by checking the test expression, almost like asking, should I keep going or stop here? If the answer is true, it happily jumps into the body of the loop. Does it work? And then circle back for another round of questioning. This cycle repeats endlessly as long as the condition stays true, making it feel like a determined little hamster on a wheel. But the moment the test expression says false, the loop finally takes a break and exits gracefully, saying, that's enough for today. Now comes the do loop. In a while loop, the test expression is evaluated at the beginning of the loop. If the test expression is false when the loop is entered, the loop won't be executed at all. In some situations, this is what you want, but sometimes you want to guarantee that the loop body is executed at least once, no matter what the initial state of the test expression is. When this is the case, you should use the do loop, which places the test expression at the end of the loop. Let me explain it with the help of an example. So here we are initializing long dividend and a divisor char ch. This is start of do loop, and here we are going to do some processing. Enter dividend, C in dividend, C out enter divisor, C in divisor, C out quotient is dividend divided by divisor. C out remainder is dividend modulus divisor. C out do another yes or no, do it again. C in ch, which while ch not equal to no, which is a loop condition, return 0. Okay, most of this program resides within the do loop. First, the keyword do marks the beginning of the loop, then as with the other loops, braces delimit the body of the loop. Finally, a while statement provides the test expression and terminates the loop. This while statement looks much like the one in a while loop, except for its position at the end of the loop and the fact that it ends with a semicolon, which is easy to forget. The syntax of the loop is shown in this image, which is saying that do does not have a semicolon, and the test expressions along with the while statement does have a semicolon here. Same is the case with multiple statements loop body. This flowchart tells us the tale of a do-while loop, which is like that one friend who acts first and only asks questions later. It jumps straight into the body of the loop, saying let's do this at least once, no matter what. After finishing its job, it politely checks the text expression to see if it should keep going. If the condition is true, it eagerly loops back for another round of action, and if it's false, it finally bows out and exits. Think of it as the optimistic loop that promises I'll give it a shot at least once. Now, when to use which loop? The for loop is appropriate when you know in advance how many times the loop will be executed. While loop is generally used when you may not want to execute the loop body even once. And we use do loop when you are sure you want to execute the loop body at least once. You can actually make any of the loop types work in almost any situation. You should choose the type that makes your program the clearest and easiest to follow. Now coming towards the if statement. which is the simplest of the decision statement. Let's see its code. Initializing the variable x, enter a number, C in x, if x is greater than 100, then that number is greater than 100, return 0. Okay, here the if keyword is followed by a test expression in parentheses. The syntax of the if statement is shown in this code. As you can see, the syntax of if is very much like that of while. The difference is that the statement following the if are executed only once if the text expression is true. The statement following while are executed repeatedly until the text expression becomes false. Multiple statements in the if body. The code in an if body can consist of single statement or a block of statements delimited by braces. Let's understand it with the help of example. Taking the previous code, just modifying it, see out the number x, see out is greater than 100. And let's debug it. Enter a number. The number is greater than 100. Okay. Moving forward to next topic, which is nesting ifs inside loops. The loop and the decision structures we have seen so far can be nested inside one another. You can nest ifs inside loops, loop inside ifs, and ifs inside ifs, and so on. Let's understand it with the help of an example. Unsigned long nj, which is going to give us only positive results. Enter a number, C in n, for j is equal to 2, j less than equal to n divided by 2, j plus plus. And here 2 on up, if remainder is 0, it's divisible by j. And here it's not a prime, divisible by j and l exit 0, which exits from the program. See out it's a prime number. Okay, in this example, the user enters a number that is assigned to n. The program then uses a for loop to divide n by all the numbers from 2 up to n divided by 2. The divisor is j. The loop variable, if any value of j divides evenly into n, then n is not prime. Notice that there are no braces around the loop body. This is because the if statement and the statement in its body are considered to be single statement. If you like, you can insert braces for readability even though the compiler doesn't need them. Okay, this was all from my side regarding for loops, while versus do while loops, if statements, choosing the right loop for the right task, real world examples, and clear explanations to boost your programming confidence. Thank you so much for watching the video.